In this issue, let's discuss the latest progress of subsea data centers. The world's first commercial subsea data center, developed by Highlander, has been running smoothly for nearly a year, since it was officially put into operation at the end of March last year. Highlander also participated in the MWC 2024 World Communications Conference in Shanghai. On June 25, 2024, according to an interview with the head of Microsoft's cloud computing operations, Microsoft has quietly shelved its subsea data center project, named as Project Natick. Let's briefly introduce the project of Microsoft, the pioneer of subsea data centers. The project was first launched in 2013. The prototype was completed in 2015. Microsoft conducted a 4-month experiment in California. After finding it feasible, it officially launched Project Natick. In June 2018, Microsoft sank a data center with a length of 12 meters and a diameter of about 3 meters into the seabed of Scotland. This data center is loaded with 855 servers and is ready for a 5-year-long reliability testing. Although Microsoft's project has been shelved, according to the analysis of Data Center Dynamics, only 6 of the 855 servers encapsulated in the underwater shell field, while 8 of the 135 land servers used by Microsoft as a control field. In percentage terms, the underwater failure rate of 0.7% is significantly less than the land failure rate of 5.9%. Why build an undersea data center? One of the most important reasons given by Microsoft is that undersea data centers reduce costs. According to statistics, the annual energy consumption cost of global data center accounts for 30% to 50% of the entire IT industry. Many data centers spend a lot of money to buy air conditioners or fans for cooling. Putting the data center in seawater can solve the most basic heat dissipation problem of servers. Because the mass of seawater is large, the flow is wide and the temperature is very low. The server can solve the heat dissipation problem by using the surrounding water flow. Additionally, undersea data centers are more environmentally friendly, using wave power to provide more clean and sustainable energy for the servers. Microsoft, while not giving a clear reason for the suspension, said they are currently focusing on researching how to use robotics to improve data center operations. In addition, Microsoft is studying other ways to power data centers, such as modular nuclear reactor. Now let's take a look at what Highlander has done to successfully operate the world's first commercial undersea data center. From a technical point of view, Highlander uses the same undersea data center technology as Microsoft, from an internationally renowned subsea technology company called OceanWorks International in British Columbia, Canada. The company specializes in designing and manufacturing manned, unmanned submarine systems and special equipment for the military, oil and gas, scientific research, and other marine markets. It has been at the world's forefront of deep diving and diving technology, operations and support for more than 20 years. At the end of March 2023, the world's first commercial subsea data center, developed by Highlander, entered the sea in Hainan and was officially launched. The core equipment of the subsea data center, submarine data cabin, has an application depth of more than 30 meters, weighs 1,300 tons, equivalent to about 1,000 cars, and has a tank diameter of 3.6 meters. It is currently the world's biggest subsea data cabin. How to put such a large data cabin on the seabed? Highlander chose to join forces with Offshore Oil Engineering, a subsidiary of CNOOC with over 40 years of experience. Offshore Oil Engineering built a large tank for use at a depth of 300 meters as the main cabin of the subsea data center. In addition, Highlander also solved the problems of sealing safety and unmanned maintenance of the subsea data center. For example, seawater corrosion and microbial attachment, as well as leaks caused by water pressure, can allow seawater to enter the data cabin and cause equipment failure. In terms of maintenance, Highlander divides the maintenance issues into two modules, inside the cabin and outside the cabin. Redundant backup is performed for the IT electromechanical and power supply parts inside the cabin. For the HVAC electromechanical equipment outside the cabin is also backed up, and divers can quickly replace it underwater. Compared with Microsoft's solution, Highlander's solution also solved the problems of natural cooling of seawater in high seawater temperature areas. Although in 2022, Highlander and its 4 subsidiaries were included in the Entity List by the United States, this also proved its advanced technology.